Sriram, programmer from Team 6547's Cobalt Colts, here today to help you sense a signal using EasyOpenCV's AprilTag plugin in this year's game, PowerPlay. Before we step right in, let's go over what an AprilTag is. AprilTags are basically mini QR codes that robots can detect with high accuracy. One of the reasons why many people should use AprilTags this year, compared to other alternatives like TensorFlow and plain color detection, is that it's very immune to lighting and perspective differences. In other words, AprilTags can be sensed very well in a lot of different view angles and a lot of brightnesses as well. I have made a sleeve template using three of the different tags for AprilTags from a 36H11 family of tags, as you can see, namely tags 1, 2, and 3 for the positions. You can print that out using the link in the description below. You will also need a legal webcam. For example, this is a webcam I'm going to use. Logitech C270s, 310s, and 920s are what I would recommend. Coding wise, you need to have Android Studio set up and be able to connect add files to the robot. So that means you'll need also a control hub with a battery, a charged battery, and you can also have a driver station phone or a driver hub. You can also use an expansion hub and a robot controller along with the driver station. I'm currently using a MacBook, so I'll be uploading my code to the robot using TCP/IP and ADB. But there are tutorials on Windows and Mac on how to upload code using wired connection. I'll post a link to first official Android Studio guide in the description as well if you need help. Finally, at the time of recording, the FTC SDK 8.0 has recently been released. I will be showing how to code a bot using 8.0. However, while demoing the bot, I will be using SDK 7.2 instead, as some of the libraries I use on my robot has not been updated to be compatible 8.0 yet. However, the code is going to be all the same, everything in the team code folder. So yeah, I'll also be sharing the code on GitHub in the description as well, so no need to worry. EasyOpenCV is compatible with 8.0 now. Before we get started, one last thing, make sure to like, subscribe, and share the video with other teams. Alright, first thing to get started is that we're going to download the SDK from First Tech Challenge FTC Robot Controller on GitHub. I'll post a link in the description, but this is the link for us here. But you can also use GitHub to clone it, but for the simplicity of this tutorial, I'm just gonna download the zip file, save it into my desktop. Click this, it's gonna expand, and then I can just press open desktop. That's fine. Here we go. You go trust the projects. Right, here it is. As you can see, there's something saying Gradle's project syncing progress. Um, Here is basically where all the dependencies are going to be loaded into the project, so you can use stuff like FTC dashboard, Roadrunner, and obviously here we go use EasyOpenCV. But we had to tell the project what are we going to import. So it's going to take a few minutes depending on your Wi-Fi connection and CPU stuff like that. So I'll meet you back when it's done. Alright, everything has finished loading. So now, as I said, Gradle files are going to be important, but first I want to show you where you go write all the code. So as you can see, I'm just going to close everything out. There are basically three big things here. We got an FTC robot controller. Here you're really not going to be updating a lot of code here. It's mostly like sample files and other important stuff. But as you can see, there's sample files. If you want to see some concepts, you can obviously use these. And then here's the team code. This is probably the most important of all of this, along with Gradle, because this is where you go be writing all your code. So you can see you open Java, then you see org, first and fires, FTC team code. This is basically the team code place. And here's the readme, so you can read through all this if you want. And finally, here are the Gradle scripts. For now, we are going to be using EasyOpenCV. So let's get started with adding the dependencies for EasyOpenCV. To do this, I opened EasyOpenCV. By the way, this was all credits go to OpenFTC who made this in the first place. And I'll post all the links in the description and including the final resulting code so you can compare this. Alright, So we scroll down, they gave us an installation instructions, and you need to do all this. So first, it says open the Android Studio project. Well, we already have that. Check. Open a build.gradle for file for the team code module. So this is gonna be this file over here. So this is the name of your main file, and then this is a team code module. So you're gonna open here, and yeah, as you can see, we got a few things over here. And what are we going to do next? Next, it says that we have to add this implementation. Dependencies implementation org.openftc EasyOpenCV 1.5.2. Gradle files are hard to understand, but you can think of this as like importing the code, the libraries needed to code. That's like the one of the simplest ways to explain it. But yeah, so now as you can see, we added dependencies 1.5.2. Now we open the build.common.gradle file and scroll down until you find the spot. So let's open build.common.gradle first. It's this file all the way on the top. We're gonna open that. See there's a good amount of lines. Oh, by the way, these errors, they're just false positives. You don't have to worry about them. Delete them. Now let's see what it says. It says that we need to find around like line 82. We need to find all the ABI filters and remove all references to ARM64 V8A. As you can see, this is the reason why we're doing it. So let's find where they are. So it's like around line 80, I think. No, it's a bit below that. You can also just search for it if you want, but it's somewhere around here. No? Okay, my bad. I didn't see it. So as again, you're just gonna delete this, backspace, backspace. Yep. Okay. Now perform a Gradle sync. This is basically updating your Gradle files. As you can see, we have this blue header saying that Gradle files has changed since last project sync. A project sync may be necessary for the IDE, or in this case, EasyOpenCV, to work properly. So now it's important you press the Sync Now button, and it's going to take a few seconds. That's pretty quick. Yep. So now you probably won't have any actual errors. Check your things again. Should be good. Now this is the most important part. Without doing this, you can't use Easy OpenCV. Basically, you need copy this file, so you can click on this when you get to it. Or you can also go search it here, docs, native libs. But basically, you find this for folder, and then you put it in the first folder of your control hub or expansion hub. Now this is pretty tricky, so I'm gonna show you step by step how to do that. Alright, I have my control hub connected to a battery here, and as you can see it's flashing blue, so that's a good sign. So it's not flashing blue, but that basically means it's on. So now we're gonna put this file inside the control hub. So for you Windows users using USB probably, what you're gonna do now is connect from the USB, USB-C, not USB 2.0. You go connect from USB-C to connect to the USB 2.0 A or B to your computer. So and then you'll be seeing the files, all the files inside the control hub, and then you go move this file folder into the first folder. I'm using Mac right now and it's using ADB, but I'll just show that first we're downloading this folder. Yep, we'll show in Finder. It's on my other screen, but I'm just gonna copy it. Yep, and yeah. Alright, so after I copied it, what I'm going to do now is connect to the robot network. Obviously, if you're not using Mac, some of these things might not be necessary. I think for if you're connecting by USB, connecting to the robot network should not be really necessary. And then since I'm using ADB, I'm just going to ADB connect into 168. This is basically the IP address and TCP/IP port. But yeah, now as you can see, I connected. So it changed over here. Now I'm just going to show you the file explorer. For Windows users, this is actually much easier as you don't see all these files here, but you can just find it somewhere around here. I'll skip to when I find it because it might take a while. System app, no, not here. Yeah, it's a bit hard, but it's a really important step. Send this. No, it's probably not in the system folder. Blocks, class, firmware, no, storage. No, it can't be here. SD card, yeah, sorry, that took a while. As you can see, I am pretty sure I already should have this file folder here, but I'm just gonna show that you're gonna you basically go upload the folder you got. So I have it in desktop, so it's lib. You basically use this, and then you press open, and you basically put it in the first folder, and then you'll add that file over there. So you can see I already have it here, and so that's very good. This is an important step to do once again, just to reiterate. But yeah, after you're done with setting EasyOpenCV, and now we're going to move on to setting up EasyOpenCV-AprilTags plugin. So there's a few more steps we got to do. All right. As you can see on my screen, I have the EasyOpenCV-AprilTag plugin GitHub open. I'll set there'll be a link in the description, and it's this link right here. Yeah. So once again, we'll open the build.gradle file. And this is why I I made you all have to install EasyOpenCV, because this is a plugin. It still needs to have EasyOpenCV um for code there. So here we just go copy this. We're going to build.gradle file for the module team code. Once again, that says this here, or you can click here, and then either you can just do this, but since I might be having a lot of libraries later on in the season, I'll just post it in this dependency, so no redundant code. And then now that should be it actually, assuming you already have EasyOpenCV done. So after that, you have to sync project with Gradle files again, because we made an update, we added a new library, so we're going to do that. All right, now OpenFTC really helped us and had some example op modes to use. So basically, for camera detection, you're gonna have usually two different files. One of them is the pipeline. This pipeline is able to do operations with an image that's and return the final image. People call it a mat. But yeah, this is a pipeline that processes your image, or like image from a video. So this is the pipeline, and it gave us some sample code here. Once again, credit to the OpenFTC team. As you can see, there's a bunch of code, but it's also pretty advanced. But we won't be poking around in this. What we're actually going to be poking around in is this file. This is the autonomous init detection example. So this is basically the auton you're coding. The auton is going to be using, technically it's an auton, but I know it's a teleop, but we'll change that the end if we wanna, but for testing we'll leave it at teleop. As you can see, basically this is the run off mode, so it's the important start of a function code, and then this instantiates your camera, and you set the pipeline of the camera, so it'll start doing processing um, code, but then you also need add camera.start streaming, and then on error, in case there's an error, like stuff isn't plugged in. So then here it's going to start scanning, and then we're going to be editing a lot of this part, because we're going to be scanning for three tags. We're going to be scanning for three tags. This code is for scanning one tag, but so we're going to do some minor tweaks to it, and yeah. And then we also have some if statements, sample if statements. You won't be needing this until later. And then we also have some important telemetry we can use. Um, I prefer that I'm not going to be really using this, but you can keep it if you want. Yeah. So once again, here are the example codes. So now either you could just like download this whole thing and like, I don't know, like find these two files and then copy them over. But what I'm gonna do is, honestly just like create in team code. Obviously, in fact, I'm gonna make the code cleaner for you, and I'm gonna call make a new folder. So here it's called package. We'll call it auton, and then we'll do a new Java class, and then we'll copy this name because we need a class to have the same name as the folder. You can always change the name later for this, and then you also have to change the class name. So then there's this copy button over here, so we can copy it. Control Alt, paste, and now we're going to have a lot of errors. This is the reason. The reason is the package is long. Package is basically like the location of the folder. We need to add .auton because we made that folder ourselves. As you can see, the errors are going away. We still have some. We didn't create the pipeline. Now we have to add a pipeline folder. This is searching for the um, class named AprilTag detection pipeline, and we don't have it in here yet. So now we go add a pipeline. So new Java class, and then let's copy the name AprilTag detection pipeline, and the name is here. Press enter, and then now once again we're going to be copying. Control Alt, paste. Yeah. Now we only have one error, so it's pretty obvious it's going to be the package. We'll just do .auton. No errors here. And as you see, the squiggly lines are gone, so no errors here either. Awesome. Now, what's next is that we're going to be modifying this code. So we can scan for which pixel, which Apple tag is going to be in in view for the camera, so we can sense the right position, and if I recall correctly, you're going to be able to know the location and then park in a correct location, and that should give you 20 points. Yeah, as you can see, if you use this was only 10 points, but you made your own custom sleeve, so now it's going to be 20 points. So that's really big points this year. So it's really important to be able to do this challenge in Auton. You'll have a big edge against other teams. Alright, now we're here in Auton here, and we're gonna go top to down and then see what we can change to sense all three QR codes and find which one's the correct code. So first we start here. So this basically calls the camera, and this calls the pipeline. This is a conversion unit. And then these, I wouldn't bother changing them unless you want to know like the exact location. Same with this. Unless you want to know the exact location of where your cone is, the distance of it from the robot. But the main goal here is to actually just, detect the QR code. So I won't be changing that in this video. But yeah, so first we need have three tags of interest. So it makes sense to do int left is equal to 1 because as I said earlier, the left tag is going to be called 1, int middle, my bad, middle is equal to 2, and then int right 3. And then we won't be needing this anymore. When we delete it, there's gonna be some errors because we haven't changed this to left, middle, right yet. Don't worry about that. And then I'm gonna change comma to 1, 2, and 3. So these are tag IDs 1, 2, and 3 from this family of April tags 36H11. Now we're just setting the tag of interest to null because we haven't sensed any tags yet. In fact, the pipeline hasn't even started running, so we don't even know if that's even a tag. And then now that's a lot of code. I think I said earlier, but this basically turns on the camera, sets the telemetry, and then here before you play the robot, so you'll start by tapping once. There'll be a init, and then doing the init, it does all this. So now we create array of current detections, and then we use the pipeline to get all the latest detections. So let's say if the current detections is not 0, so that means we detected something, we go say the tag found is false. Um, yeah, and then for April tag, because we haven't found the correct tag yet, but we know that that might be a detection. So for April tag detection, tag in current detections. So for everything in current directions, we go check for the tag of interest. Tag found basically means that we go check if it's the tag of interest. So as you see, we want to see whether it's left, middle, or right. So we're going to use some OR conditionals. So we can do tag ID is equal to left or tag.id. This basically that's an ID and it's going to be 1 to like 24. So like tag ID is equal to 2. We can also do that, but to make the code readable, I set that earlier here as left, middle, and right. So we're going to use that. Or tag.id equals right. Then we're going to set the tag of interest to the tag here. And we're going to say the tag found is true. So we know that we found a tag. And if tag found, we're going to be logging a lot of telemetry here that helps us. For example, if there's a tag, we say the location data if we need it, and we'll say talk about we'll tell what tag it is as well. If not, we don't see it, then we can check if it has ever been seen once, or if we already seen once. Yeah, or if we never have seen once actually. And here you might not see the tag of interest. Uh, you can also say that the tag has never been seen. Same thing with this, but you might have seen the tag before. And then now you update the telemetry with all this data. Every time you press this, every time this code gets run, note that this is a while loop, so it keeps on going until you start the op mode. So and then it waits 20 milliseconds because pretty sure that's because we need to be able to get another picture. So we go sleep for 20 milliseconds. After this, if we exit this, as it says, now we are gonna, that means a human player has pressed the play button and the robot's actually gonna start moving. So what this is gonna do is it's gonna use a latest position it got. So that's gonna be stored in tag of interest. That's gonna be the latest position. Here it says if tag of interest is not null, so it exists basically. We can say that there's a snapshot. We'll talk about it, and then we will talk about more of the tag of interest, the distance if we need it. We'll update as well. If not, you can also say we didn't scan anything and it's going to stay as null. So we have to do some null safety so your auton actually doesn't do nothing, right? So here we have a if else statement. So what I'm going to do is for this game we really don't need to know about how far the QR code is. What we need to know is what QR code is this. So I'm actually going to delete all of this. So for you, it's going to be lines 170 to 196. And once again, I'll have all the code from here onto GitHub, so no need to worry if you can't get confused. So here, let's do, see if I deleted everything I needed. Yeah, all right. Okay, so now we're going to check for starters if it is null or if it's in the left. So we go say if we couldn't find any tags, we just go tell it to go use the left trajectory. So you know there's at least a 1 in 3 chance we can park correctly. So we can do if tag of interest equals null. So basically this means it doesn't exist. Or we can say tag dot id tag of interest id is equal to left. You can default by left, right, middle, but honestly it's just gonna be a 1 in 3 chance if it's null. So then here we go put your trajectory. So basically the code that makes this move. So move to the park in the left side. If not, we go have an else if. My keyboard's dying. Excuse me. Else if, and then we can say tag of interest dot id. This is once again this is saying the numerical ID. So we can do middle, and then we can do trajectory again. Else, that means if it's not null, not left, not middle. We can also do else if right, but we don't have to because we know now the remaining IDs go be right. So trajectory again. Finally, that's it. And then now, if you're having an actual auton, you will not be needing this as this says, but we want to keep it continuing for demo purposes. So like when you actually have an auton, you should delete this because this means it's just going to be running all this code. It's going to be, it'll run this code once, but it's going to stay there. But this is opmo is going to keep running. So instead, what you're going to do is delete this and then add like other code, you know. But yeah, we'll keep it like that. Finally, this is a method here that basically adds all this, including the detected tag ID, and uses the parameter detection, so basically the tag of interest. And it gives you all the translations and rotations. Once again, you need to have like the correct values for these and the tag size, which I haven't measured, but if we want to do that, go that way, you should tune it. Yeah, so now we're done with this. Once again, we don't need to mess around with anything of this. It's just scanning it and using a pointer to start detecting, and then we're gonna run code that's gonna search for if there's any April tags. All right, now I think we're ready to start moving this to the robot. See you then. Alright, now we'll go over on how to actually connect the camera to a control hub. So you go open your driver station. I'm going to assume you're using a control hub and a driver station. If not, you just do this on your you should get the expansion hub connected to your driver station and turn on your driver station. So I'm going to do it right now. You can also use a robot controller if you're using an expansion hub, and using that you can kind of scan for the webcam you're going to connect onto the robot. So I'm just going to wait for it to load. And then as you can see, I got my battery and control hub ready to go. And then a Logitech webcam and a USB 2 port. So it's finally on now. So I'm going to swipe up. And now it says it's on. Now it's loading the driver hub. Alright, now obviously it's already connected because I've been using this before with the controller. But basically to do it, you're just gonna go to settings. I press restart robot. Settings. You go be in settings right now. Can't see well, but I'll just say settings. Then you tap Pivot Robot Controller. Make sure your pairing method is instead of Wi-Fi Direct, you use Control Hub because we're using the Control Hub. If you're using expansion of actually, you should keep it Wi-Fi direct because you're connecting two phones. So yeah, and then you wait for the connect to the controller using that. So now we have it connected. What we're gonna do now is um, we're gonna scan. But to do that, let's see how we do it. Right now, I haven't connected my camera yet. So it just says right now the control hub portal. Now it's a bit hard to see. I'm sorry for that. Um, but it's gonna it's gonna say controller portal because you don't have anything else. But what you're gonna do now is actually take your camera. You have a camera over here. Um, Make sure it's connected to a battery, obviously. And then you're gonna put this. There's a whole port of USBs here. You're gonna put it in any one of the USB 2.0 ports. So I plugged in the 2.0. Go set it down. And then now the camera isn't turned on because we're not using it yet. But what we're gonna do now is now you're in your configuration, right? Once again, let's see how you go get there. I'll show. So you go to your configurations tab, click edit on a configuration, and then now you press the scan button. So like the top right scan button. And now it always says that there's a webcam and its name is webcam 1. You can leave it like that because the code assumes that I'll actually show you. But the code actually assumes that the name is webcam 1 as you see. So there's no need to change the name or anything. Make sure you press the save button. It's going to ask you to enter a name, press OK. Now you press back and it's going to manually restart the robot. Great. As you can see, now it has restarted the robot, and whenever I'm going to press this, and you can see it's hard to see, but you can see there's an Android logo, and to the right it says AprilTag Autonomous Init Detection Example. And I know it says autonomous, but it's in teleop right now, so you can play around with it. Alright, now we are getting almost ready to push the code to the control hub and start testing it. Can't wait. Alright, now I think we're gonna be ready to push the code to the control hub so we can actually see this in action. Once again, I'm using a Mac with ADB, but I'm gonna assume that you're connecting your control hub to your computer using the code bit, using the USB 2 to USB-C cable with the USB-C connected to the control hub itself. And then if we did it correctly, you're gonna see that it's gonna save the control hub and then you should be able to press the play button, and it should push the code down. If not, if something goes wrong, sometimes a lot of times actually, it might have trouble pushing code. There's a guide I linked in the description, and finally, if you join the FTC Discord, you can always ask questions there, and they have helped me and everyone else a lot. So I really recommend doing that. So as I said earlier, I'm going to be using the 7.0. So in other words, I already pushed it to my robot. But yeah, to push it once again, just press run team code, make sure it's connected, make sure there's no errors, all your Gradle syncs are done, your lib435 OpenCV is already on the control hub, as said earlier. But yeah, when you're ready for that, you can press the play button and it's going to upload code. And first time, if it's your first time, expect like a few minutes. Honestly, it's going to start building. It'll take a while, and finally it's going to end with installing it. So it's going to take some time. Alright, without further ado, I'm going to skip uh, until you're done and we can see it in action. Alright. So now you're after pushing the code to the control hub, you're gonna be on your driver station and you're gonna find the teleop that says AprilTag autonomous detection example like this. And now what we're gonna do is start testing it. First we go by the way, this is my little practice field here to mimic the real condition. Basically it's gonna be like a full tile apart, so I kind of made it around that distance. So it also works behind it, so you can check. But what I'm going to do now is actually press the init button. So now after pressing the init button, you're going to be before the play button. And right now you can actually see that it's detecting ID tag 1. It's hard to see, but it's saying ID tag 1. And what I'm going to do is press the top right sandwich menu, so the top right three buttons, and go click on camera stream, and then hopefully this is better to see. As you can see, we have a little cone. It's basically showing what the camera is seeing. Now it's not live, so you have to keep on tapping for it to refresh. But if you can see, there's actually a green box detecting the code, making a little box of the AprilTag, so it knows what it is. And now we're gonna stop it. Go press init. I know it doesn't see it, but now it started it. So I'm currently at 1 right now. I'm gonna switch it so the tag should be able to be seeing 2 right now. So now it's saying 2. And basically I'll show the camera stream. And once again it's detecting number 2 and telling us it's number 2. Now I'm gonna stop and init again. It keeps on saying it's number 2. Now I'm gonna turn it, and now it's going to be a position number 3. So now it even says that now it's at ID number 3, as you can see. Camera is sensing it. And once again, camera stream. You can see it. And yep, that's it. Now we have a successfully censoring, being able to sense the signal using a custom sleeve, using AprilTags and EasyOpenCV. So now all you have to do is be able to program the drivetrain. So this is not a robot at all, but you need to program the drivetrain for it to move, and then you gotta program it to park in the correct locations, and the 20 points are yours. So hope this tutorial helped. If there's any problem with my code, please let me know in the description. I'll also be putting my Discord username in it, so you can always just contact me. You can also contact the FTC Discord if you have any general questions. And everything I used here, any sources of code, repositories, links will be all posted in the description. Make sure to like, share the video with other teams who could use this, and subscribe as we're going to be making more tutorial videos soon. Thank you.